Hey everyone, and welcome to probably one of the last installation Kubeflow videos. So I'm going to work on other things other than how to install Kubeflow. And I might come back to the subject in a little bit, especially if it changes, and as well as when the Kubeflow operator is really graduated out of alpha, probably into beta. I will do a series of videos on that, but my general install videos are probably coming to an end. So this last one is going to be installing Kubeflow on minikube, and I hope you enjoy it.
3, 2, 1, 0.
The No Channel.
All right, so Kubeflow on minikube. Why would you want this? So the biggest advantage that minikube gives you is the ability to quickly and easily stand up a Kubernetes cluster to run applications on. And for me, the biggest reason you'd want this is, while it's not really a production thing, it is a really great prototyping thing. So this gives you the ability to easily prototype things like your Kubeflow pipelines. So you're wanting to work locally on this pipeline, on this XYZ, and it gives you a really great reason to do that. A really great way to do that. Now, why I wouldn't use minikube and Kubeflow or any of the local installs, minikube just happens to be my favorite out of these, is I wouldn't use it to train a model. I wouldn't use it to do any machine learning at all. And the reason is it's not meant for that. Kubeflow isn't meant for that. Kubeflow itself is for orchestrating large amounts of machine learning. So everything from the data to the training to the serving. That doesn't really make sense locally. You don't serve locally. You don't really care about hyperparameter tuning locally. Not as a corporation. Now, as an individual hobbyist, I can kind of see, but I'm going to give you some solutions to that later, that and I'll link where in the video those to that location in the video that really would fit your needs a lot better in a local scenario. So really what I think that the best use of these local installs are for is just working out the kinks of those things like the pipelines and some of those things that you can do that aren't heavy on workloads. It's already heavy enough, so you don't want to add anything more. So the first thing you want to do is get minikube. I already have minikube downloaded and installed. You guys don't need to see that. There is a link in how to do that on the Kubeflow instructions anyways. So go ahead, get that. Go ahead and get KFCTL for the version that you're running with. And I've already done that, and I've already exported my config URI, so we can look at that. Config. So if you notice, I'm building the version 1.0.2, and this is the KFCTL Istio install. So it's pretty simple. The next thing that we're going to do is we're going to stand up a minikube node to run this. Let's look at that command. It's not too complicated. There's a couple things to keep in mind. First, I don't have 6 CPUs on this laptop. I have exactly two CPUs. And so I'm going to share 2 CPUs. That's all I have. The recommended is 6, and really it doesn't run well with just 2. Now, this is the first thing. There's this VM driver equals none. Now, in their documentation, in the minikube documentation, they recommend the VM driver none. And really, this does some things that it may be good, may not be good. I don't like it as much as the KVM2 driver. So you can run it in the KVM2 driver. I do a lot of stuff in KVM, and what I really like about this is it segregates it. If you do the none, the driver none, it's actually the Docker driver, and it runs everything in Docker. And as you'll see a little bit later, it explodes your if you run Docker PS, there's about a bajillion things that are running in it. And so if this is your workstation that you're working on and I run some stuff in Docker, it's not really nice to have all of that crap shoved in there with it. So for me, I would actually like to run with KVM2. That being said, the KVM2 driver requires a little bit more work to share the GPU. So if you are really dead set on training on your laptop or your workstation because you have a really beefy workstation, the KVM2 driver is more difficult to share your GPU with. If you run with the none, it's very easy to share your Docker driver or your GPU driver with Docker. But the KVM requires you actually having extra GPUs. So to share a GPU with KVM, you have to have two, one for the host that's running and one for the VM to share to it. And then you have to do all that. And that's a decent amount of work. So if you're not taking my warning and really actually want to train your model in Kubeflow with a GPU, you can do it. Now, that also being said, not all workloads are optimized. All machine learning workloads are optimized for GPUs. There are things that actually perform better with their training with a CPU. So don't discount. And now, if you're wanting to do images and whatnot, recognition is done better with a GPU. So there is that. But a lot of stuff, like especially data and whatnot, can be done on a CPU and sometimes even slightly better. So don't think you have to have a GPU. All right, moving on. CPUs, memory, disk size. You're going to need a decent amount of disk. 120 gig is like the bare minimum that you're going to need. The rest of this is pretty easy. We're setting RBAC. We're setting to the run system resolve conf. And then we're setting up this pre-flight errors for kubeadm to skip a pre-flight errors check. All right, so the other thing that you'll notice, so this is going to run, this takes a little bit of time. It's running on Docker, as you can see. So another thing that you're going to have is Docker installed. Now, this is a problem I wanted to show you that I couldn't get around. And maybe I'm doing something wrong, but when running with none, I couldn't run without sudo, which is a pain in the butt. So when running with VM driver of none, I couldn't run without sudo, which is kind of a pain and I don't really like. We're going to do it today for example purposes, but when you're doing it with like KVM and whatnot, I think it's a much cleaner environment setup. Also, when you're doing it with none, it does kind of mess with your environment just a little. Not as much as some others, but it does. So here we go. We're going to run with sudo. I really wish that minikube, if anybody from the minikube community is listening, this would be one thing that I would like to see changed. And this is going to go off and launch Kubernetes. Now, this is almost done, but I know that a lot of you guys have also been wanting to see some pipeline examples and demos, and those are in the works. Pipelines is something that I'm working on making a fun and interesting video for. Actually, so I'll let you know, all of these videos are actually accumulating to some stuff. I have some interesting projects that I'm trying to work on that hopefully will tie all of these things together. I'm also looking to hopefully provide a community resource for you guys that allows you to partake in some of these things. So whenever I train a machine learning model, hopefully I can make it in such a way so that not only do you have the trained model, but you have also all the data used to train that model so you could reproduce it yourself if you wanted to. And that's really my goal in a lot of this, is to just create a community of learning and sharing. All right, so it's done. We now have a Kubernetes cluster in minikube. This is why I don't like using the none driver with sudo, because now if you want to use kubectl, you have to run sudo kubectl get nodes. And you can move all this stuff to your user to avoid using sudo, but then I have connection problems because the certs are still owned by root. And so then I have to move the certs, and then I have to tell my kube config where the new certs are. So it's actually a larger pain than it looks. Just running these two commands isn't too bad. It's actually a lot more of a pain because of the certs. And because of that, it takes like 5 or 10 minutes to make it so that I don't have to use sudo. I'll just use sudo for the time being. All right, so our cluster is running. Here, if you started it with VM driver none, if you want to expose your GPUs at this point, it's very, very simple. So the only thing that you have to do at this point is this command right here. This is applying the NVIDIA device plugin. Now, we can apply this to our cluster. It won't work on this laptop because its driver isn't supported. So you have to have a CUDA empowered one. While this laptop has a very, very old, I think the laptop is 5 years old, and it might have been a year-old laptop that when I got it on like a sale because it's being discontinued. And it really doesn't have a GPU. So, it has an integrated GPU. So anyways, it won't work with this. And it won't provide one. But this is all you'd have to do to provide the GPU to your cluster. And so if you're really set, you're really wanting to train models on this and that need a GPU, this is how you would do it. You would just apply this. It will be applied. It's going to create a daemon set. If you don't know what a daemon set is in Kubernetes, maybe I'll make a video on the different types of deployments because there's static pods, daemon sets. That would actually be a good series of videos. So I'm going to do that. At this point, we have a minikube cluster and we have our daemon set. So let's go ahead and deploy our minikube. So since everything is set up and configured, all we have to do is do our kubectl apply or kfctl apply. If you don't know what these commands are, this is just saying verbose. The -V is saying be verbose. And the -f is saying from this file, which can be, because it's the Go module, it can be a URL to a file. It can be a file directly in your path. So that's what we're going to do. All right, so what you noticed here, and this makes complete sense in this aspect, is that it had a problem. So 500 could not sync cache, and it's having this problem and permission denied. And that's because our minikube set, right now we need to run kubectl with sudo. So let's clean up really quickly. So what we want to do is run this command with sudo. And that's going to allow it to talk to our cluster. So this is talking to the cluster. It's just going to use whatever kubectl manifest file is there. So if you have multiple manifests, make sure kubectl is set up to point to the cluster you want to deploy to. And it's going to go off and do it. This is going to take a little bit of time to do. So I'm going to be nice and fast forward through this. But before I get to fast forward, I'm just going to talk about some of the other options for hobbyists and local deployments. So if you're really wanting to train and do something locally, right now, the best option, and why I say right now, is I'm actually working with some people to hopefully bring you a better local playground environment. But until I help bring that to you guys, right now, what the best thing to do is there, and we'll switch over to, actually, this will be really good. Check this out. This is why I don't like running it with driver none. Check this out. All right, So if you notice, this is all in my desktop's environment. So if I was running in KVM, it would all be in a virtual machine. And I could ask Versh for a list of machines running. So we could do something like sudo Versh list. And I don't have any virtual machines, but it would have the one minikube. It would be called minikube, and it would be the virtual machine. So because I'm running it, not only is the control plane and all the Kubernetes stuff, so you'll see the core DNS and the kube proxy, but you're also going to see the Grafana, the Istio, the KF serving, and all of the Kubeflow things also in my environment. So if this is on your, I highly recommend, unless if you're wanting GPU and ease of use, I would highly recommend using the KVM2. I have tested it and Kubeflow works just fine in it. And I think it's a much cleaner install. We can see that it says successful here, successfully applied. That doesn't mean it's done. You can't just jump from here and go ahead and open up the UI. Check this out. So if we do sudo kubectl incubeflow, so the in is just saying the namespace. Kubeflow by default installs into the Kubeflow namespace. Get all. All right, not everything is running. So this is actually the second time through. And so all of these pods were already downloaded, and so it was up a lot faster. But this, the very first time you run this, it's going to take probably, I would say, about 20 to 30 minutes. So you're going to need to watch this for all of these to be ready. And it's going to take a little bit longer than it does here because some of these images are actually quite big, and it's going to take a lot of time to download. The second time you do it, your Docker registry, your local Docker registry already has the images, and you won't need to download them again, and it will be much faster. Now, you can get this IP address by typing minikube IP, and you can get this by typing, I will put the command up. You can ask Istio what its IP address is. And here is a welcome screen. Now, if you actually go before all of the components are up, you won't get the welcome screen. And so if you don't get this welcome screen, you need to just wait a little while because you won't have a namespace to work in. So it doesn't hurt anything. You just need to wait a little while and go check on the status. So we get the welcome screen. That means everything is up, and we can go ahead and make a namespace. So let's call this, because I'm so original. Now, remember, mine is a little laggy because I only gave it 2 CPUs. It's not a great experience, but we have our local distribution, and now we can do our pipelines. And again, this is where I really think that Kubeflow locally is awesome. When you can do these pipelines and debug them and work on them locally, especially, really, you should have a development environment with a real Kubernetes cluster. But when you're just getting started, it's a great way to learn. But again, this is where Kubeflow is really designed to bring it from training to production to serving. And this is why I don't really think that it makes a whole lot of sense to run Kubeflow locally as a means to train a model and test a model. It's not really what it's designed to do. And so that's why I don't think the upstream community works at supporting it locally as much as some would hope, just because a lot of its goals are in that data center-esque realm. All right, that is your Kubeflow install. You can do it with the KVM2 driver or with none. Pick your poison. And I hope that helps. Now, if you've heeded my words and are really interested in what I would recommend let's go back over here quickly. And I would recommend you do this. Minikube. Oh, wait, we have to run with sudo because if you run, check this out. If you run with minikube delete, minikube with the none driver is actually really close to doing what kind does, except that kind, the difference between Kubernetes minikube with the none driver and kind, and I didn't go into this in a whole lot of detail in my last video, but the basics for it is that kind actually runs a whole node image. So you add a node, and that worker node is a single Docker image. What minikube does is it's only a single node. And so all of the things run in Docker. So it's a little bit different, as in with this, you don't get any virtualization, and with the none driver, you would have no second worker or whatnot. It's just on that one machine. But it gives you all the components right there. And it doesn't do the whole Docker inside of Docker. So because those that doesn't need to exist. So yeah, it's just all running in the same Docker. Your control plane components and the and the pods are running in the same Docker. So anyways, that's just the big difference. All right, so we deleted our minikube. I always just run it also with sudo because we started it with sudo, and we're good. All right, let's do what I think is the easiest way if you're just looking at training a model on your laptop and running with it. Right there. I'm sorry you didn't see. Okay, look. Here we go. Docker pull TensorFlow latest GPU Jupyter. This gives you a Jupyter notebook with GPU support in Docker. I don't like running TensorFlow on my laptop if I don't, or any of my workstations if I don't have to, because it's a really messy install and it's kind of gross, and I don't like having it there. And that's really what containers give you the power to do. And because Docker supports your GPU pass-through, it's really easy to use this way. And it gives you a Jupyter notebook that you can go and we'll test this out. Now, again, this poor thing doesn't really support a GPU, but it will work. I can do it on this one, which has a 2080 in it, and which CUDA supports. And that's actually how I test my models with the TensorFlow Jupyter notebook on my desktop, is with the latest GPU Jupyter, or actually I use the 2.0, but you can use whichever version you want with the Jupyter in it and GPU. Now, again, this is a pretty big download. It's, I don't know, I want to say it's like 5 or 6 gigs in total. You can see some of these already exist, and that is from our Kubeflow install. All right, so, and then to run this, all you have to do is run it like this. So we have the latest GPU Jupyter. To run it in Docker, you just have to type docker run, then gpus all rm NVIDIA, and then whatever container you're wanting to launch. I don't actually have an NVIDIA one. I have the TensorFlow one, so we could launch the TensorFlow latest GPU. TensorFlow latest GPU Jupyter. Again, I don't have a laptop that supports the CUDA, so I can't actually share this, and I can't do this with you guys because this laptop doesn't support it. So what I'm going to do is I'm going to then take a screenshot of my desktop, and I'm going to show it and just do a voiceover for it. So it won't be live like I do a lot of the stuff. Well, I guess, yeah, kind of live. I guess it's recorded, but.
Okay, I'm over here on my desktop, and let's go ahead and do Docker PS. Nothing's running. Let's now do Docker images. And you'll notice we have a couple images here. So this is my setup here. And one of the really greatest things here that you can do is I don't have to have TensorFlow installed in my environment. All I have to do is have these Docker containers, and then I can mount paths to them. But simply and easily, let's go ahead and check our install just so you see what a standard install looks like. So first, you're going to be able to run ls pci, and you can just go ahead and grep for NVIDIA instead of looking at all the output. So you'll notice that we have a VGA compatible controller. This is the line we're looking for. These actually don't matter at all. So we have NVIDIA controller. Now let's check if this is a CUDA powered GPU. So to do that, we can do NVIDIA SMI. And this is actually going to tell us about it. So we do have, not only do we know our CUDA version, we know that this is a CUDA empowered GPU. In fact, it is a 2070. I think I said 2080 earlier in the video. That guy doesn't know what he's talking about. It's a 2070 though, and it should be right here. 2070. So you can see that's what it is right there. So now we know that we're all set here. We can run a test and run the NVIDIA CUDA container. So you can see here, this is just a NVIDIA container that has CUDA installed in it. And so let's just do that. Let's do Docker run GPUs all. And then we're just going to run SMI in it. And you'll notice that it doesn't have all these processes because these aren't owned by the container. So only the container's processes would, but you get valid output. It knows what GPU it has, and this was inside this container. So that's awesome. Let's go ahead and run a Jupyter Notebook. Is to run this command. The one thing that I'm missing here, I always forget this, is GPUs. All right. And now we can go ahead and copy and paste this right here. Open up the good old Chromium. Make sure you remove that. And we have a TensorFlow powered Jupyter Notebook powered by a GPU. We can test this out. This is a Python 2. You can get in a different one. But if you want to figure out if your notebook has GPU support, you can paste this in like this and run this. It's going to give you this deprecation warning. That's par for the course. And you can always use this here if you like to see if you have GPUs. So, and you can see this has a type of physical type of GPU with GPU. So, latest. I don't remember if it was GPU or. Okay. Latest GPU Jupyter. Whoa, misspelled Jupiter. Jupyter. All right. Latest GPU Jupyter. And now we can just go ahead and run this. It will give us this. We can go ahead and... Oops. No, I don't want to exit. I do want to copy this. Let's jump over here, open up Chromium, paste this here, remove that. And now we have a Jupyter notebook. Just to verify that it actually has a GPU in it, let's go ahead, make a new Python 2. And there's this really easy set of commands that you can run. It says they're deprecated. I haven't looked for new ways of running this, but basically just TensorFlow. There's the test is GPU available and is built with CUDA. And we can run those. And we're going to get the warning for deprecation, but we also get that we have a GPU is available and is built with CUDA. So, this is what I find the easiest way to work in dev. So not only do you get a Jupyter notebook, but if you want, we can look over here and let's go ahead and close this down. So if you're looking over this here, oops, I meant Docker images. If you're looking over these images, you can just use this here and run a command straight in it. So you can do something like docker run let's see, which one were we saying we'll use latest GPU? And then we're going to do just run Python. And you can do something like this here. I have it ready for pasting, so we don't have to type that all out. This is just in the TensorFlow documentation. So, and so what you can do is you can just pass TensorFlow with command line arguments and use it that way as well, and just execute them in TensorFlow. Let's see. No NVIDIA GPU is present. Ooh. Oh, okay. So this is interesting because what we didn't do in this case here is we said GPU. So we picked the image that supports GPU, but we didn't. If you notice up here, let's look what we normally we're doing is we gave it GPUs all. So we need to do that. So there you go. We did it with, you see that it did its GPU. So we trained something on the GPU. And yeah, that's pretty much it.
Thank you everyone for sticking around and watching this video. I know it was kind of a long video. I hope that you found this information helpful in some way. And stick around, subscribe to the channel if you're interested in machine learning, if you're interested in Kubernetes, and or you're interested in learning how some of these things are going. I'm going to be uploading a very much beginner into computer science set here soon. I'm actually teaching my children computer science, and these are some of the lessons I'm going over with them. Thought I'd record them and upload them if they help some people. They won't be the same as my normal content. They'll be very much towards beginners and actually young children, going over like logic and things like that. So anyways, hit the subscribe button, stay tuned. Thank you very much for joining me, and I look forward to bringing you some more content in the future.